In the last video, we talked about the 4 different methods we've used to solve quadratic equations and how to tell when you should use each method. So what I thought we'd do this time is go ahead and take these 7 equations and sort them into which type we think would be the best for each. Now the quadratic formula and completing the square will work for any of the quadratic equations that we have. So let's look through the square root method and solve by factoring to see which ones we should start with there. Now the square root method only works if there's a squared thing. So we're looking for equations that would either have just an ax squared and a constant term, maybe equaling 0, or that would have a parenthesis with a squared and maybe a coefficient and a constant term. So looking through our equations, this is in standard form, so it's not going to work. Same for this one, this one, this one, and this one. So if we look at the 2 remaining, we can see here we have a squared thing, x plus 5 squared equals 18. So that can easily be solved by the square root method. So we'll put that here. And 9x squared equals 625 kind of looks like this format. So we'll put that also in square root method. Solving by factoring will only work if our equation is factorable. So if we can kind of quickly look and see about factoring an equation, if it looks like it would factor very easily, then we could put it with the solve by factoring. This x squared minus 7x minus 60 looks like it might factor. The 2x squared, well, those with a leading coefficient, we'll hold on to those for a second because they take a little bit longer to factor. So let's go ahead and put this one with solve by factoring. Because I'm thinking with 60, like 12 and 5 would combine to give me 7 when I subtract them, so that might be an easy one. Completing the square and quadratic formula. What we have left are 4 equations that are in standard form or could be made in standard form very easily. The completing the square problems say that it's easiest if a is 1 and b is an even number. So we're looking for a coefficient of 1, or that we could make the coefficient be 1 and still have an even number for our b term. If we look at this coefficient of 2x squared, the coefficient is 2. If we divide every term by 2, we're going to have 5 halves for b, because b will not be an even number, it will be a fraction. So let's not do that by completing the square. Let's put that with quadratic formula. And look at what we have left here. Well, this one does have a leading coefficient of 1 already, and if I divide, or I don't have to divide anything by 1, I look at the b term, and it is even. So this is a good one for completing the square. Then we have these 2 left. If I divide this by 2, b is not an even number anymore, but b is just 1. It's not a fraction, so it's a little easier to deal with. We should maybe put this one by the completing the square, because I'm not going to let you do more than 2 of any type. So we'll put this with completing the square. And then 3x squared minus 5x minus 3. If I divide by 3, then I have really a lot of fractions, 5/3, and that won't be fun to deal with. So we'll put that one by quadratic formula. Then we'll come back in just a few minutes and we will go ahead and start solving by each of these methods.